Thank you. How y'all doing? Okay, well, Connor and I, we're the anchors here, so we'll try to get you to the reception. I'd like to talk to you a little bit about today, the MU Biomass Energy Project, and in particular, am I out? My mic's not out? It's not on. Might as well be. It's kind of cutting in and out. Okay, anyway. The MU Biomass Energy Project and engaging community stakeholders to ensure a sustainable program. We'll talk a little bit about the background of the project, sources of woody biomass as we have in Missouri and the relative availability. We'll also look at stakeholder engagement and the process we use, but then also speaking to the sustainability standards that we put in place in our fuel supply contract. Theodore Roosevelt said it best, do what you can with what you have where you are. Where we are is in central Missouri, halfway between St. Louis and Kansas City. I want to point out we're on the northern edge. Thank you. We're on the northern. Am I going to have to I'll stand by the podium then. Okay, we'll just do that. I can't walk now. Okay. Anyway, we're halfway between St. Louis and Kansas City. The one thing I want to point out, we're on the northern edge of Missouri's wood basket, as you can see here. A little bit about the MU campus, about a 600-acre campus comprising about 340 buildings, 13 million square feet of classrooms, laboratories, hospitals, and a nuclear reactor. The star up in the front, at the top left corner, that's where the energy plant is located. A little bit about the energy plant itself. It is a combined heat and power plant. It produces about a little under 1 million pounds of steam per hour, capable of generating up to 66 megawatts of electrical energy if needed, supplied by 5 boilers, 4 steam generators, and then we have 2 natural gas turbines with heat recovery systems on the back end. Overall thermal efficiency of the plant is just under 70%. And as a result, in 2010, the EPA recognized it as one of the top leaders in district heating and cooling and energy needs. About 4 years ago, actually 5 years ago, in a brown bag seminar we were having, I got to meet Greg Coffin, who's one of the co-authors of this presentation, and understood that they were doing this program. They were thinking about putting in a boiler, changing out one of their existing boilers. And at that point in time, I said, and it was going to be wood-fired. They'd done a lot of tests with tire-derived fuels and corn cobs, but they found wood chips was going to be their best way to go. And I said, from a forestry perspective, if the forestry department wasn't involved in something like this, then we had no business being a forestry department at the university. About 4 years ago, the project was put into place, and 2 years ago, the construction was started. When it is done now, but when it's fully operational, it will, combined with our co-firing of our existing 4 stoker boilers, will reduce our coal footprint by 40%. It was about a $76 million project, completed right before the holidays, and right now we're in the commissioning phase, and we're right at 66, 70% full load. Once it gets to full load here, we suspect in another month, that one boiler will be consuming 100,000 tons, coupled with another about 30,000 tons for the co-firing of the other 4 boilers. So that's a sizable load. It's one of the largest, if not the largest, biomass energy project of any major university in the country. More importantly, though, that $3.5 to $4 million that we're going outside the state to purchase Southern Illinois coal will now be staying in the local economy for supplying and empowering our economic engine there. A little bit about our biomass fuel. It'll start out 100% wood, eventually go down to 80%, and then ag residues will ramp up. The boiler is a bubbling fluidized bed boiler by Babcock & Wilcox, designed to take about a 20% mix. Although they'll also be looking to push beyond that envelope. The power plant, I must point out, is very proactive, including me in a lot of the early on design processes and working with the fuel supply contract, but also working with the College of Engineering. Because one of the things they want to do is in the swing seasons of spring and summer, they'll actually push that envelope a little bit further and then take it down and let the engineers crawl in there and see what the effects of the grasses will have on the system. The woody component comprises mainly of mill residues and wood waste, and we'll talk about that here in a second. Harvest residues, which where I factor into a lot of things, and then storm debris as well. The agricultural component will be comprised of ag residues such as corn, stover, which we have a lot of there in central Missouri, and perennial grass crops such as cool season fescues and the native warm season grasses. So the primary mill residues, what we're talking about, those are the slabs and edgings, the cutoffs, the log cores from taking a round tree and making square dimensional products from. Our secondary mill residues then come from the cabinet shops, cooperages, the barrel plants, flooring, and pallet plants. This will comprise probably about 80 to 90% of that woody component. A little bit about, like we say, we're on the northern edge of the wood basket, but within a 90-mile radius of Columbia, there are sufficient mills that will be supplying that mill residue. We'll also be taking wood waste, non-treated, clean sawn lumber, recycled pallet plants. Another component we'll have in there will be right-of-way clearings, urban tree trimmings, and then when we get that occasional storm surge of a windstorm or an ice storm, that can factor into the mix too. And not only taking it from the Columbia area, but working with the folks over in St. Louis. Now, harvest residues, that's where I come in more as a forester. Those are the tops, the branches, the crooks, the other portions of the tree that are normally left behind in a commercial timber harvest. But we'll also be looking at those trees that are structurally weak, having low vigor, lacking the potential to ever generate a commercial log by the next time we visit that forest. Or if that tree, we figure, the forester decides, probably because of that low vigor, won't be around in 10 years, 10 to 15 years in our neck of the woods, that's when we re-enter for a harvest. Real quick snapshot of the economics of our woody biomass supply chain, and it's not unlike what we see in the pulp and paper industry here in the Southeast. Starting with standing timber, the landowner will probably receive $1 to $3 a ton, green ton, for its stumpage or the value to the landowner. But then through mechanical harvesting, feller buncher, grapple skidder, bringing that to a landing, and then, so this is all done in conjunction with a commercial harvest, one pass system. Otherwise, if we try to go in and just take biomass out, the economics just aren't there. They come into the landing, they're segregated out, the biomass is then chipped and blown into a van and then taken to the facility. So from forest, if you will, to furnace, and an 80-mile radius, you're looking at some delivered cost to the gate of about $32 and change. Now that doesn't factor in the risk factor and the profit factor for the biomass handler or supplier. So right now our contract calls to the supplier, it's about $35.64 with fuel adjustments. So you can see it's got a little bit of wiggle room in there for their profit, but it's pretty darn tight. So, where's the wood? This is a typical shot. This is looking across the Missouri Valley from the south to the north into Callaway County, which is just east of Boone County where we live. But you can see besides the bottomlands where you'll have a lot of agricultural residues and row crops and maybe short rotation woodies later down the road, the mix is pretty much a mosaic. And that mosaic is also in 85% of the land ownership is owned by private landowners. And then within that, it's pretty much an equal mix between a third row crops, a third pastures, and then a third into the woodlots. What we've done is we've developed about 4 years ago, not only to help MU, but also anyone in the state, particularly government planners, entrepreneurs that are looking to locate a biomass facility. So we took the U.S. Forest Service forest inventory data and put it in a spatial analysis tool where an individual can place a plant anywhere in the state, go out up to 2 hours away in travel time, bring in public land, bring also in degree of operability of the slope, and get some kind of estimate on the green tons. So everything is here is on a green ton basis. But we also will factor in participation rates of the landowners, because we know 1 out of 10 landowners right now actively manage their woods or do any kind of timber management. And so we don't expect everybody to jump on the bandwagon. We think it'll be somewhere in that 25 to 30% participation rate. So what we're trying to do is paint a realistic picture to government planners and entrepreneurs and enterprise folks that it's not just because you see, when you fly over the Ozarks, you see a sea of green, that it's all going to be available. We want to make sure that we're painting, if you will, a realistic or definitely a worst case scenario. From that, we identified, this is where it gets in, I'm an extension agent as well, state extension specialist. And so taking that information, going to the county courthouses, a lot of them aren't electronic databases, digging out those landowners that have 40 acres or more of timber on their property, and then inviting them into community forums. Here, Greg Coffin, the plant manager, he is explaining the project itself. But we also invited in the Sierra Club. We advertised this so anybody that was out there could come in and learn about the project. We wanted to be completely transparent on what was going on. Also, Steve Foster Brothers, they were the ones that were awarded the timber supply or the fuel supply contract over a 10-year period. He was there to explain the process, and then I followed up as we moved into the sustainability standards. And this is where I really kind of worked with the power plant. I would sit in engineering meetings, and so I learned a lot about engineering and designing a biomass facility, but they were also there to learn from me the sustainability standards. And we had long conversations as far as making sure that they understood that we needed to be proactive rather than reactive, and have these sustainability standards on the front end and actually set the lead in the state. We have no biomass facilities in Missouri. Typical national average was for every 4 that are announced, 1 comes out of the ground, and that's what we had in Missouri. About 2006, we had a bio-oil plant. We had a couple of 10 to 50 megawatt generation plants proposed, and the University of Missouri is the only one that's come out of the ground since 2006. But what we wanted to do, and we built this in the fuel supply contract, and we wanted to make sure landowners were aware of this, but also the environmental concerns, because we needed those folks to be the eyes and ears as this project unfolds. And the first thing is, it says in the contract that all lands harvested will have a written management plan developed by a professional forester. Once a particular stand is called to be harvested, the harvesting will be done in accordance with our woody biomass harvesting BMP guidelines, our best management practices. Those were developed or adapted from our folks in Wisconsin and Minnesota, and they're voluntary in Missouri, but the contract says you will follow these. We also have the requirement that there will be at least 1 team member on each harvesting crew that will have passed through the Missouri Forest Products Association's Professional Timber Harvester Program. That's about it's a 5-day, 40-hour course. Of course, they're not going to be master loggers. That's the next gold standard, but it does give them the basics. And just last week, the power plant underwrote the first Mid-Missouri workshop there and paid for all the registrations, because we wanted to send a signal to the logging community that we were serious, but we weren't going to just give them a mandate. We wanted to help them become educated and make sure everybody was on the same page. Some of the things, though, what we will not take, and it says so, that we will not convert forest land to cropland. A lot of corn acreage has been pushed out, riparian corridors, expanding the acres. We will not take that wood. We will not take wood from forest land that's converted over to hayfields or pasture. And in the urban fringe in Columbia, unless there's already a building permit, we will not take wood from speculation where they're going to just clear off the site and let it sit there for development. We don't want to be a part of that. To do all this, it's trust but verify, and the power plant will then hire an independent consulting forester that will go out, and it says here, randomly selected harvest sites. Probably what we're looking at is, on an average of about 400 to 500 acres a year, because we're not going to do chain of custody back through the primary and secondary mills. We're talking about working right immediately with the logging crews, so that wood is coming directly from the forest into the plant. So that's about 400 to 500 acres, might be as much as 1,000. Usually acreages are about 100 acres up there, so we're talking about 10 or 12 tracts. Early on, we'll probably be doing more than just a periodic review, because we want to make sure everybody's on the same page. And we've developed a scorecard, so that will be the forester will go out and take that out there and evaluate the program. One thing I forgot to point out, back to the loggers, We also require that they retain, either on staff or they hire a contractor of their own choosing, to be with them to make sure those guidelines are adhered to. Because it's always hard, once that logging crew leaves the site, to get them back. We want this to be an educational process so that if an outage does happen, it's caught while they're still there and it can be corrected. The consequences are pretty simple. Failure to comply could serve as a grounds for termination of the contract. Now, the point that I'm bringing out back to the professional foresters, as well as taking it back out, not in defense of the loggers, but we know that there are going to be outages. We really haven't developed a supply chain that's from scoop to nuts, if you will, and we know that as we go through this process that there will be problems. It's like a manager of mine once told me that, it's okay to make a mistake. You learn from the mistake. If you make the same mistake twice, then we've got issues. And that's the kind of the approach that we're taking, going in, working with the logging community. This quote from Konrad Adenauer, he was the first vice chancellor of West Germany, I think kind of sums it up. It says, we all live under the same sky, but we don't have the same horizon. And when I put that in here, I was thinking pretty myopically. I was thinking our horizon in Missouri, our wood basin, is a lot different from our southeastern brethren. But then hearing the other presentations today, going from the nanoscale up to the regional scale, it's a lot more. But we want to, so we all have our different horizons, but the vision's the same. We want renewable energy to be a significant player, a significant contributor to our national needs. And that's what we're all working for. And with that, I appreciate your time. Thanks for listening. I'll be happy to entertain any questions.
Thank you. Questions? Right here in the front.
So thank you for that roadmap to something that I envy at the University of Georgia. I wish we could do something like that. But you mentioned this $76 million investment. That was because the boiler needed to be replaced?
It was an existing biomass boiler. It never worked. It was a kind of a first generation, and they knew that was needed to come out. The university actually sued the manufacturer and won that many years ago. Oh. So they made it work, but then they realized they wanted to bring it out. And that bubbling fluidized bed, that's really a diverse system, a very versatile system, rather. And so what they did is they went to the Board of Curators. They priced it out. On an energy therm basis, our woody biomass is around 275 to 280 a million BTU. That compares with coal. And at the time, that was quite a bit cheaper than our natural gas contract that we had. Now, of course, gas prices have dropped, but our natural gas contracts are calling for I believe it was 3.25 to 350 a million BTU. So, but when looking against that, and like I say, they were very forward thinking. They just said, it's the right thing to do. We're going to do it. I cannot say enough for the energy group there. And for them to take that boiler is going to be, it's not a surge. At first they thought it was going to be kind of a peaking, kind of more experimental. That's going to be 25% of the base load of campus. When we're on our high demand times, campus draws about 52 megawatts. So, and they shut that steam how they need to for their energy and their heating and cooling needs. But it's been just a real privilege to work with those folks.
Thank you.
Another question? There's one right over
See
here.
one back over.
Yeah, I'm Bill Tollner from the University of Georgia as well. Thank you for that. And I was curious to know what percentage of the total power or the total electric power consumption of the university that you're able to meet with this system, or you project meeting?
It's 100%. Oh, I mean, the whole facility, like I say, we can meet all the energy needs.
Oh.
And we do have a black start, because we have that nuclear reactor on campus, the medical reactor, we also have a black start. So if the power went out like that, the campus wouldn't miss a beat. We also are tied into MISO, and so what they do is if they can generate power at, I can't remember, if it's lower than what they can buy, they will actually buy off the grid and then take their equipment down, their downstream generators, and do their servicing then. They're very proactive, and we'd never take the power plant down. So like I say, under full load, it's about 52 megawatts, and they have 66 that they can generate, so they've got a cushion.
One more question, right up here.
I was going to ask you, what is the capacity factor on your biomass plant?
The capacity factor,
How often is it running compared to when it's not?
it's running, it's 25% of the base load. It's running 24/7, 365 days. Right now, it's just in the commissioning period. So they've had some issues, not really with the boiler itself, it's been more with the fuel handling system. The one thing I failed to point out, not only that 76 million, that also what they did is they siloed all the coal and the biomass. So once it's offloaded, the biomass and the coal will never see the light of day until it reaches the furnace. And it's right next to a creek that runs through Columbia. So now it's all concrete now, and all their catchment is contained, so nothing gets into the creek. It's all their gray water's all recycled, and because it's a distress stream that goes into what we call the Hinkson watershed. But no, the plant, that boiler runs, it's base load.
I'd like to close with one more
Sure.
question and go back to, you identified small landowners maybe at 40 acres, and then you said really not mandates, but it looks like you guys were really driving the sustainability issue towards the landowners and towards how or I guess through the loggers, and how the harvest would be handled, whether there's replanting going on and all of that. Could you just speak to how that was maybe received because those of us who know the forest products community, how did that go over with your sustainability initiative?
Well, the logging community is really, they're all for it, because they realize it's their bread and butter too. They don't want to, it's not a clear-cut operation. When we can take about 20 tons of biomass off of a harvest, and that's leaving a residual forest. We do a lot of shelter wood type, it's an oak hickory type, so it's pretty much a shelter wood, or even we can do, because we have more xeric site, drier sites, we can do single tree selection. And so you're taking off, you're meeting and all the traditional forest products, as well as the biomass, and leaving the residual forest. The landowners are seeing the need. We live in a pretty environmentally conscious part of the state, and so they're embracing that. And the environmental community, actually, when we rolled this out to the local chapter of the Sierra Club, they asked me more questions about the emission standards, which I graciously passed off to the power plant because I didn't have all that information. But they had no issues with what we were doing. A cautious eye, because again, I wanted to caution them as well that we are going to have outages. But the point is, we want to make sure that we catch them early on and we all learn from it. And that we set the standard in the state for other biomass projects that do come out of the ground, that if the university can do it, then it should be able to be done, in the Ozarks.
All right, thank you.
You're welcome.